You made it back. I'm so excited. All right. Hopefully that attempt on example 1 went well. Let's look at example 2, which incidentally, example 3, #awkward, it's just part of example 2. So what we'll have you do is maybe try that on your own here just in a moment. Okay? So for example 2, a pedestrian signal at a crosswalk has the following cycle. Walk for 45 seconds, don't walk for 70 seconds. What is the probability the signal will show walk when you arrive? Well, let's kind of just draw this out in a picture and make this make a little bit more sense. So the first part, and actually we'll do that. Yeah, we'll just stick with this right now. The walk segment, maybe, come on. Oh, that's a great W. We'll make that work. It is going to be 45 seconds in length. Okay. Then it goes to don't walk. Okay, so do not walk. And that's going to be 70 seconds in length. Okay? So what we have there is the situation with you are allowed to walk and then don't walk. So walk for 45, then don't walk. What they want to know, well, what's the probability that the signal will show walk? So you need your whole. So the probability of it walking. Well, that is easy. The numerator, the part, is going to be 45, right? The portion that you have there is going to be that 45, okay? But then the whole sample space is that entire time that the signal was going. So that would actually have to become 70 plus 45, which would be 115. So that's going to be the entire sample space that you have there, just to keep that in mind. So then you just reduce that, okay? And what you end up getting there, once you reduce that, would be a value of 9 over 23, or 0.39. I'll be honest, I prefer this, that out of 23 total, 9 out of 23 total times, you're going to get a walk signal. To me, that makes the most amount of sense. Okay? All right, so in example 3, which is technically the second part, if you arrive at the signal 40 times, predict how many times you will have to stop and wait more than 40 seconds. You're waiting 40 seconds. Okay? So what you want to keep in mind is that if you are going to have to wait no more than 40 seconds, you have 70 seconds when you could walk. You want to wait no more than 40 seconds. That means there's 30 seconds left where you would not be walking out of 115 total seconds. But then you approach there and you're going there 40 times. My gosh, whoever's doing this, we need to get them a freaking hobby, right, people? Like, seriously, you're going to go to the same signal 40 times and see if it freaking walks? For no more than 40 seconds you have to wait? Over you. Done. Anyway, 40 times you're doing this. You're repeating that 40 times. So we're literally going to just take and multiply that by 40. Okay? Multiply that by 40. So when you do that, just get a decimal for that. This is a big number. That's going to be 10.43 approximately 5. And the unit on that would be the number of times that would occur. Oh my gosh, that's literally the worst 3. See, this pen is just like me. It's about done, people. Okay, stay tuned for example 4. We'll get you a question on this one here. A little tricky, but you got to take the 70 minus the 40 to get 30 seconds that is remaining there, which is the waiting no more than that. Look at the color coding. I did that to help. All right, come back for the last video. I'm pumped. Are you pumped? I hope you are. Good. Okay, good talk. Good talk, everyone.